In this example, we want to compute the volume of a solid based on the cross-sectional areas. So we're told the base of this solid is the area inside the circle x equals r squared in the plane, and its cross-section is perpendicular to the x-axis, r squares. I want to find the volume of this solid. So in this case, the problem all depends on this value of r, so the answer we get will also depend on r. So to start, let's draw out this region. So this is just the circle of radius r centered at the origin, which means we know that this point here is at r0, this is at minus r0. Now we're told things about the cross sections perpendicular to the x-axis, which means I'm looking at slices this way. I know that on top of each of these slices, I'm putting a square. Then figure out the length of that slice, and then its area is just going to be that length squared. So what's the length? Well, the length of each slice goes from this top curve to this bottom curve. And based on the equation for the circle, we know that we can rewrite this as y equals plus or minus square root of r squared minus x squared. And so the top curve is the plus version, and the bottom curve is the minus version. So what does that mean for how I want to set this up? Well, that means the length is then top minus bottom, which since the top is the plus version, the bottom is the minus version, gives me the length should be root r squared minus x squared minus negative root r squared minus x squared. Or the length is just twice root r squared minus x squared. So that's the length of each slice. Now then the area, because they are squares, the area is just L squared. The area as a function of x is L squared, or 4 times r squared minus x squared. And then to find the total volume, I want to integrate this area over the entire object, so from x is minus r to x is plus r. Remember here, r is a constant, and x is your variable. So when you integrate this, the 4 can come out front, and I'm going to get inside r squared times x, and then minus x cubed over 3 from minus r to r. We can then plug in our endpoints, and we'll see each of these terms looking like r cubed minus r cubed over 3. So that's 2r cubed over 3. That's going to make 4r cubed over 3 when I cancel out all the negative signs. And then multiplying that by 4 gives me a final answer of 16 over 3 r cubed. So that's how you would find the volume of this object defined by its cross sections using an integral with volume by slicing.